For today's topic, we are going to talk about the rate of reaction, which is the change in the amount of products or reactants per unit time. Did you guys know there are 4 factors of the rate of reaction? The first one is size, the second one is temperature, the third one is concentration, the fourth is catalyst. For today's presentation, we are going to connect the factors of the rate of reactions with our life.
What is chemistry? So chemistry is a branch of science that studies properties, composition, and also structure, and changes methods of life. It seeks to understand how the substances interact with each other, how they combine, separate, and also transform, and the energy changes involved in these processes. Chemistry connects other scientific disciplines such as biology, physics, and also environmental science, providing a foundation for understanding the material world. Speaking of the world, last month we went on a holiday to the beach to have a barbecue party. I wonder if our adventure could be connected with chemistry. So yeah, let's find out.
We got there by driving a car. I was thinking, don't cars emit harmful pollutants? I searched the internet about how cars reduce harmful pollutants. Now I know it is because of catalytic converter. Well, the catalytic converter is an important tool in the vehicle exhaust system that works to reduce air pollution. It uses catalysts such as platinum, palladium, and rhodium to accelerate chemical reaction without running out to convert 3 harmful compounds in car exhaust. In the catalytic converter, the catalyst changes from carbon monoxide to carbon dioxide, hydrocarbon to carbon dioxide and water, and lastly, the nitrogen oxide into nitrogen and oxygen. For your information, with catalytic converter, it could reducing harmful gas emission that can cause air pollution and the greenhouse effect. And it also protect human health from the effects of toxic gases such as carbon monoxide and nitrogen oxides.
A few moments later.
As we arrived, I suddenly remembered that my mom told me before to apply the sunscreen to our face as soon as we arrived. But I think why? Why we need to put the sunscreen to our face? And I asked my mom, Mom, for what the sunscreen really is? And she got tell. But luckily, my father is a genius. So he tells that actually sunscreen contains chemicals that react with the UV radiation from the sun. These chemicals absorb the UV rays, preventing them from reaching your skin. But my friend asked me, if you put more sunscreen to your face, then the more effective it will be. But the statement is absolutely wrong. Okay, so by putting a lot of sunscreen won't change the effect. So imagine the sunscreen as a shield. A thin layer of shield can block a certain amount of sunlight, but adding too much sunscreen won't necessarily make the shield stronger. In fact, it may be even decrease its own effectiveness.
After that, I unrolled the carpet on the sand, set up the umbrella to shield us from the sun, and took out the snack from the cool container and enjoyed the refreshing treats in the shade. As I enjoyed my snack that had been put in the cool container, I noticed how it affected everything around me. The glass of water I had beside me stayed cool longer and the condensation on its surface seemed to form more slowly. When you need to know for its when the temperature decreases, molecules move more slowly. In the case of the water, the cooler air environment reduces the molecular movement, slowing down the evaporating and exchange of the heat. This allows the water to remain cool for a longer time compared to warm environment.
Before I started grilling, I prepared a small size charcoal to use for the grill. The small size charcoal in the grill burned brightly and provided consistent heat for cooking. I remembered that smaller pieces of charcoal had larger surface area to volume ratio, allowing the combustion reaction to occur more rapidly. This larger surface area ensured that the grill would heat up faster. When the grill are ready, I started placing the chicken on the grill. As the chicken sizzled on the grill, I noticed how the smaller pieces cooked much faster than the larger cuts. The heat easily penetrated the smaller pieces, allowing them to cook evenly and thoroughly. It reminded me how surface area and heat transfer go hand in hand, making the grilling processes more efficient.
While Naufal grilling the chicken, we dive into the ocean. In the morning, we know that the cool breeze from the ocean begin to blow, and I start to shiver in the water. The sudden drop in the temperature made my body react involuntarily to generate heat. I asked Amru about it, and he said shivering is a response that helps warm the body by increasing the metabolic reaction. The muscle contract rapidly when exposed to the cool and generate heat in the process. This increases the rate of energy production through shivering, help raise the body internal temperature, illustrating how temperature can speed up biological reaction to keep us warm.
A few inches later.
After I finish grilling, I invite them to eat together. During the meal, I overheard Alif discussing about digestion. He explained how chewing food into smaller pieces increases the surface area for digestive enzyme to work on helping break down food more efficiently. I realized this was similar to how the chicken cooked faster when cut into smaller pieces. It was fascinating to think about how the body uses the same scientific principle to process food as we do in everyday cooking.
A few minutes later.
After lunch, I made some lemonade drink for refreshing myself. In the meantime, I immediately noticed how the heat was affecting everything around me. The ice in my lemonade started to melt faster, and I wondered why does heat make ice melt more quickly? This is where temperature and the rate of reaction come into play. In the chemistry, temperature directly affects the speed of reaction. What you need to know, when the temperature increases, molecule will move faster. In the case of the ice, the heat made the molecules in the solid ice move more quickly, helping them overcome the force holding them together. As a result, ice begins to melt and turn into water more quickly than it would have in a cooler environment.
While I was enjoying the beauty of the beach, I suddenly memorized about the fish that's swimming in the group. I wondered how they are communicating so that they can stay in the group. I found out that most of the fish release chemicals called as pheromones into the water. Pheromones are special chemicals that act as messengers that can trigger different types of behaviors in other individuals of the same species. In the case of this fish, the pheromones might be signaling the fish to move as a group, which helps them avoid predators and find food. The concentration of pheromones in the water plays a crucial role. Higher concentration can trigger stronger and faster response of the fish. It's similar to how our own bodies react to hormones. Talking about swimming, I suddenly remembered about the rock that covered in green slime. And my friend told me that it is called as algae. So algae, what is it? Like all plants, algae relies on a vital process called photosynthesis to survive. So what is photosynthesis and how does that works underwater? Just like plants on the land, algae contains a chlorophyll, a green pigment that captures sunlight. Sunlight is essential. The algae absorbs the sunlight through its chlorophyll, the green pigment, just like the solar panels. If you ever wonder what about the water blocking the sunlight, then I have an answer for you. So the water does absorb some sunlight, but the sunlight manages to penetrate to reach the algae. So algae can absorb carbon dioxide from the surrounding water. This carbon dioxide, along with water and sunlight, is used to create the glucose, or we know as the food for the algae. Just like any of other plants in both land and water, the rate of photosynthesis in algae is influenced by several types of factors. And one crucial factor is the concentration of carbon dioxide in the water. So, as we know, the higher levels of carbon dioxide generally lead to a faster rate of photosynthesis.
You know, I could observe that a lot of seaweed was filled at the beach too. If I'm mistaken, I saw dead fishes too, but just a little. But yesterday, when I went to the beach with my family, the amount of seaweed filled at the beach decreased, and I couldn't see the dead fishes anymore. It must be decomposed by microorganisms and enzymes. Just so you're aware, microorganisms and enzymes act as natural catalysts. speeding up the decomposition of organic material such as seaweed, driftwood, or dead marine organism on the beach. Decomposition occurs when organic matter decomposes through chemical reaction facilitated by natural catalysts, including the first one is microorganisms. Key players of microorganisms are bacteria and fungi, which are the primary decomposers in sandy beach ecosystem. Their role is to produce enzyme, which is a biological catalyst that speed up the breakdown of organic compounds. Cellulase break down cellulose in plant matter like seaweed. Protease degrades proteins from dead marine animals. Lipase break down fats and oil. And second one, we have enzymatic activity. Enzymes secreted by microbes catalyze the decomposition of complex organic molecules into simpler substances, such as carbohydrate to sugars, proteins to amino acids, lipids to fatty acid and glycerol, nucleic acid to nucleotides. And then the last one, we have a biotic catalyst. Mineral surfaces in sand can act as a catalyst, providing site for reaction like oxidation or hydrolysis to occur.
As the evening comes, beach authorities organize sandcastle building competition. So suddenly, my friends asked me to join the competition with them, but I refused, and I just prefer to just spectate them from afar. As I was spectating them, my mind just randomly started thinking about the way how the sand can stay in a shape that I thought would be impossible. So to fulfill my intentions to know the secret behind this, I asked the lifeguard about this, and surprisingly, he knows about that. And he said to me, "You see, the stickiness of the sand depends on the reaction between the sand and the water, and also the grains. Adding more water initially increases the contact area between the grains, making them stick together. So like, more water equals to a stronger gusset." But he said to me, it is not necessarily actually, because too much water can actually weaken the structure of the sandcastle, because it can fill the space between the grains, reducing friction and making the sandcastles more prone to collapse. So the summary to build a stronger castle is we only need the sweet spot between the grains and the water.
While building our sandcastle at the beach, we enjoy collecting colorful seashells to use as beautiful decoration, adding a unique and creative touch to our masterpiece. But did you know about how seashells are formed? Well, enzymatic and mineralogical catalysts control the rate of calcium carbonate precipitation in the marine organism that create shells. Let us, deep down, break into the process of the seashell formation. The process occurs in distinct stages. The first one, ion transport. Calcium and bicarbonate ions are actively transported from the surrounding water or more or less bloodstream to the site of cell formation, the extracellular space. Second one, supersaturation. The extracellular fluid is maintained in a supersaturated state with respect to calcium carbonate, which is necessary for crystallization. The third one, which is the last one, is the crystallization. Organic molecule guides the formation of calcium carbonate crystal, controlling their shapes and arrangement. This precise control ensures the shell is both lightweight and strong.
As the night progressed, we grew excited about the fireworks. When the colorful explosions lit up the sky, I remembered that fireworks rely on rapid chemical reactions to produce energy in the form of light, heat, and sound. These exothermic reactions release stored energy, creating dazzling displays that bring joy to everyone watching.
Through the intricate dance of molecule and reaction, chemistry has proven itself not just a science, but a bridge that connects us with the essence of life itself, showing that every breath, every sensation, and every moment is deeply intertwined with the wonders of the chemical world.